This is Design Safe Radio, where natural hazards researchers strive to make our society more resilient to everything nature throws at us.
Some examples of NARI research projects. One of them I was thinking of is, I can't remember who did it, and maybe you can, was looking into high-rise construction project, like a skyscraper under construction, cranes and construction debris and things in a hurricane.
Right. No, absolutely. So when we think of wall of wind and some of the tests, you kind of think of structures for the most part, which is true, which is what we do. But anything that needs wind loading, anything that if it's going to get hit by a high wind and then may have serious consequences, right, for property and life and so on. So you're right. You bring up that one where they were scale models and wind loading, then pushing the wall of wind against these scale models of these huge, what they are in real life, these huge construction cranes, as you see when you see skyscrapers being built in a downtown or anywhere. And so they had scale models of those in the wall of wind, just to see, again, how can we design them stronger and make them more aerodynamic. We did another NSF project that had to do with those big electrical power line towers.
Yeah.
You think of those big towers, and is there a different design and shape that would be better for them? And what wind loading can they withstand? And so on that particular project, what was very interesting was they did it with power lines, if you will, scale power lines, this specific wire that they used. But then as another part of it, they put weights on the wires. And that was to replicate, if you think back to several years ago to the state of Texas, they had this massive winter storm, cold outbreak.
Oh, yeah.
And ice was piling up on these electrical lines. So they wanted to get information about that.
Oh, wow.
So that adds a lot of weight. So that's
sure
going to add
does.
a lot of stress.
We had that actually up here in Oregon in March.
Yeah.
We had 2 inches of ice on our everything here in the Willamette Valley. And a lot of power lines came down because of the weight of the ice.
Yeah, absolutely. So that was pretty cool. And then we had one recently. This one is very interesting. This was a first-time one. So if there be a tornado or a hurricane somewhere, obviously, when we look at social media, whether that be on X or Facebook or Instagram, and you'll see video, people taking video with their phones, right? So this particular project was to see if an algorithm could be created to where if you see flying debris on this social media video, could you then determine the speed of the wind?
Oh, wow.
So this team came and we had a structure, and then we had a roof that was open, and there was flying debris, pieces of debris that was there on top of the roof. And as we turned on the wall of wind, which we were then, they were watching the wind speed. So there were video cameras in a lot of different positions. And as the wall of wind would increase its speed, that was able to be monitored. So they are actually videotaping flying debris flying at the different speeds from the wall of wind. And so with now their challenge to then see if they can actually come up with an algorithm that would then be able to say, yes, that was a 90-mile-an-hour wind, because we could tell that's how fast the debris was flying. We shall see.
That would be really interesting because, folks who are into wind engineering and meteorology probably know this, but there's only so many sensors that you actually have when you're looking at a hurricane. There's, we got Forrest Masters and their great crew. Well, he doesn't go out on as many of these anymore now that he's a dean, but he used to go out on a lot of them. Guys like that will go out and put up big towers full of sensors, but they've only got 3 of these. And you have some other universities who do this as well, but and then you'll have water level sensors from USGS and folks like that, and then airports will have anemometers and other ways of measuring wind speed, but you have less than 100 sensors on a whole hurricane.
You're absolutely correct. The assumption might be by the public is that, well, there's instruments everywhere. But no, you're so right. There's so many airports. And then there are mobile towers, like Forrest Masters and his team might bring out there. Years ago, the Wall of Wind team used to do the same thing. But it's not like there's weather sensors on every neighborhood and every city block, right? There are more and more of these weather systems that municipalities buy and high schools buy and for lightning detection. But to be able to tap into networks like that to try and get the ground truth, right, of what is the actual wind at all these places and where damage occurred.
Right.
It's not as easy as you would think because of the lack of instrumentation in some areas.
Yeah, and so if you could get something from an X video, I mean they're geotagged, they're geolocated. You got all sorts of metadata to tell where that video was taken. Sorry if that's groundbreaking news to you listening, but yeah, we're being tracked all the time. And so you've got that precise geolocation, and if you could determine wind speed and things like that, that would be incredible useful data for helping to characterize these events.
Correct. Right. And so it's just another way to try and determine now wind speeds, because then that circles its way back to, National Weather Service wants to know how strong a storm was, National Hurricane Center, but then the research community, the wind engineering community, right? Wanting to kind of see that ground truth data on what broke, what was damaged in a certain wind speed, and so on.
Yeah, especially because, as you've been describing some of these tests, it's not just high-rise skyscrapers or school buildings, but it's also the lifeline infrastructure of a community. I mean, Miami, right? You need things like sewers and power lines and communications equipment and cell phone towers, and lots of them. And all these things that make life in the modern world possible. All of those things need to be resilient to a storm, the wind loading, the debris, the storm surge, and the wall of wind is testing all of that.
Absolutely. We've worked with transportation infrastructure, traffic signals. Many times you'll see where traffic signals are on cables. If you start to pay attention, and when you look at an intersection, and those start swinging in the wind. So how can you make those connections better? So, for example, here in South Florida, what we notice, and because of thinking wind, they put the traffic signals, and so a lot of the major intersections, on these big cross beams, these big metal cross beams. And instead of the traffic signal vertical with red, yellow, and green, they turn that traffic signal to make it horizontal on that cross beam behind it. And so again, you're more aerodynamic. It's a round cross beam, and it's whereas if because if your traffic signal is like this, it's going to catch the wind, right?
Yeah.
But if you make it now horizontal with the big giant crossbar, then there's less wind affecting it, or that traffic signal is not stressed as bad. So there are different things that you can do to improve its resilience.
Thanks for listening to today's episode of Design Safe Radio. Be sure to like and subscribe on whatever platform you happen to be listening to this on. It really helps people find our show. Thanks to our amazing sponsors, the National Science Foundation and the NARI Network Coordination Office, which is award number 2129782. Big thank you to Marty LaChance, our guest booker and topic researcher extraordinaire, and Raquel Ruiz, who is our video and audio editor. I'm your host and NARI Facility Scheduling and Operations Coordinator, Dan Zahner. We'll see you in the next episode. Until then, stay resilient.